Good morning, everyone. It's my dear pleasure to be here. Thank you, Mark. Thank you, GEL attendees. Why explore? What's the journey all about? The enduring questions that we have are there other habitable planets? Are we alone in the universe? Pretty profound. All of our outer exploring teaches us about who we are as humans and humanity in general, and really about our inner beings. The Hubble Space Telescope, now 26 years. We've known each other longer, Mark, believe it or not, but amazing. The world's greatest optical telescope has taken over 1 million observations. It's in low Earth orbit. You know, it's only 350 miles up, but it's peering into the solar system. You're looking at the Wonderland 2 galaxy, but it's teaching us about our past. It's peering into the past, into the very distant past, looking at objects that are 13 billion light years in the past. It's just phenomenal breakthrough. This is just one of hundreds, literally hundreds of missions that we have going on. Our missions are ambitious, they're large, and again, it's all about the journey, and this could be 3 decades of the scientist's life, and all of us benefit from what we learn and how that affects our life here on Earth. So 100 million observations looking throughout the solar system, throughout the galaxies. It's traveled 3 billion orbital miles circling, and it goes at 17,000 miles per hour. And then it shoots those incredible photographs, if you will, to teach us about our solar system. Galileo would be proud. And so as we journey through the universe, I'd like to take you on a journey from the solar system. Start with, how many of you last July saw our New Horizons mission? We got to Pluto. Humanity and NASA, we got through the solar system. This is our, thank you, 30 years life work of the PI and other folks. We didn't know what Pluto looked like. It's a dwarf planet. I count dwarf planets. I was a dwarf playing basketball in college, I like to say. So I'm up for dwarf planets. But Pluto has a heart. I love to tweet that on Valentine's Day. We found Pluto's heart. And more importantly, we're finding its icy mountains, what it's made out of, the chemical characteristic signature. Not a great place that life might want to, carbon-based life anyhow, but there is some ice and a lot of other chemicals. So as we go through the solar system, exploring on our journey of exploration, Dawn spacecraft. Not sure if you've heard of our Dawn spacecraft, but it found another dwarf planet. It's called Ceres. And it's the largest dwarf planet that we've found, and it's in the asteroid belt. The asteroid belt is between Mars and Jupiter. And Ceres has been winking at us, shining at us. We've been looking at it for months. And what are those shiny spots? What's on Ceres? So we zoomed in, we just got to our closest point in the orbit, and that is one big mountain. Move over Mount Everest. Ahuna Mons is 5 kilometers high and over 20 kilometers wide. So every day, I think I have the best job in the world, being the NASA Deputy Administrator. You know, this is the scientific, and I'm a nerd, I'm an aerospace engineer, so, you know, I love papers and just get as much data as I can about, you know, the breakthroughs, the scientific breakthroughs, the discoveries, the knowledge that we find every day. So where will you be on July 4th? I'll be looking at Jupiter, and I hope you'll join us. Our Juno mission to Jupiter is the largest solar-powered, off-the-grid, very far off-the-grid probe that we've ever sent out. So it reaches the closest, we've scheduled it so it reaches the closest, the apogee, the closest orbit to Jupiter. And on July 4th, we'll share the HD videos with you. And we'll do citizen science. We're going to do our largest citizen science experiment ever and say, where do you want to explore on Jupiter? Tell us where to point JunoCam, and we'll take the pictures so that we can all discover and make discoveries on Jupiter together, among its many, many other scientific instruments as well. We launched it in 2011, and it arrives now. So it's just getting, and then it'll stay in orbit around Jupiter. Incredible mission. That's just a sampling. Now I'd like to turn our attentions to perhaps our most ambitious mission that we have at NASA, and to say that first and foremost is global exploration. Everything that we do incorporates, private partners that can be from the U.S., around the world, and also our international space partners. So we're saying, this is NASA, this is the U.S., and we are taking the leadership role. These are all the building blocks, if you will, that we're committing to. So our journey to Mars with humans, we've already been on Mars and exploring for the last 50 years. So I'll show you in a minute. So we're celebrating the past, we learned so much, and then our journey to Mars with humans now is in 3 phases. It starts on the International Space Station, where we're orbiting and where we've been living. We've had astronauts and cosmonauts for the last 16 years continuously. Then we move to phase 2. That's what we call the proving ground. That's when we get back to moon orbit, Earth-moon orbit. That's the proving ground. Now we're less Earth dependent. You're 2 days a week away from any help that you might need, say in case of an emergency. Guy's going to tell you a little bit more about our exploration, our circumnavigation, sailing our boat around the world. Well, that's really analogous to this proving ground. You know, you're in the middle of oceans, you have 2 days or a week for safety. You think about it differently. You need to have more autonomous systems on board. You need to be more self-reliant. Phase 3, we get to Martian orbit, and then finally, boots on Mars in the 2030s. So that's our 3-phased strategy and approach to getting humans to Mars by the 2030s. It's quite a challenge. It's an audacious challenge, but what a journey. And as I said, we're already kind of completing our first third of the journey. Tell you a little bit more about that. But let me give you a little history here, and we'll take a look at the last 50 years of sending orbiters and then landers. And I'll show you the successful ones that we've sent to Mars. Mars is far away and it's hard. And so there's a little bit of music here if you want to turn up. I think I have a little bit of sound, but I'm going to talk over it a little bit. But every journey and every mission and every success, you know, is a huge celebration. And again, we just learned that much more. So here we are then to 1996. Some of you were born, and you might remember Pathfinder. Again, the outer journey of exploration, the inner journey and pride of all those engineers and scientists to step, you know, down on Mars. And then we move into 2000. 2001 was Mars Odyssey. 2003, the next Mars. Information overload in our world's not so bad. It takes 20 minutes for the information to get back from Mars, and so we're kind of hanging on the edge of our seat with that delay, saying, did it make it? You know, is the spacecraft alive and well? You know, do we have mission success? We call this our reconnaissance orbiter. MRO is giving us data still every day. There's our dust devils on Mars, quite a few of them actually. New landing trial, retro propulsion. We tried to test that out. We kind of land on bags and rockets in every way you can imagine, practicing, and we stuck the landing. Samples and sample returns are really important. Again, could have there ever been past life on Mars? The Curiosity rover, hope you're familiar with,
Led
2012.
by the extraordinary men and women of NASA and our Jet Propulsion Laboratory. Right now, the wheels of Curiosity have begun to blaze the trail for human footprints on Mars.
Well, today on Mars, history was made on Earth. The successful landing of Curiosity will stand as an American point of pride far into the future.
I just wanted to call and say congratulations to the entire Mars Science Laboratory team and really all of JPL. You guys should be remarkably proud.
Maven is an orbiter, and our next lander, InSight, and then the next rover, Mars 2020. That's my commitment and decades-long search. I will work probably the rest of my career, and I'm committed to getting humans and boots on Mars, as we say. We have found flowing water on Mars recently. Might have heard about that a few months ago. We knew there was ice at the poles of Mars from our probes, but just late last fall, we now can actually map and look at the water. It's salty, it's briny water. You're not going to drink it quite yet, but it tells us a lot. It tells us about seasonal change. So that's really important. You saw the MAVEN. MAVEN is an orbiter. It's looking at the atmosphere of Mars. We know how Mars now lost its atmosphere. Mars has 1% of an atmosphere. It's a nuisance. It's very thin. So when we send down vehicles, it heats them up, and we send humans, but it's not enough of an atmosphere to slow it down. So it's really hard to land on Mars, actually. But MAVEN has told us now the sun's radiation and the solar storms are basically ablating the ions off of Mars. That's an image. You're looking at ions and literally the Martian atmosphere being ablated away. That's very important because Mars and Earth, sister planets, 4.5 billion years old each. And Mars was probably a wet, habitable, lovely place to vacation maybe some 4 billion years ago. And something went terribly wrong. If something went wrong, what happened? That'll teach us about life here on Earth. So that's what we do. We look for past evidence of life on Mars, and it all teaches about here on Earth. And I believe we will be interplanetary. We will send people and astronauts to Mars coming in just the next decade or two. How do we get there? We're investing very heavily. NASA's under more development than we've been doing ever since the shuttle program, and before that, the Apollo. We are building and designing, and we will fly our space launch system. It's huge. 6.5 meters in diameter, 21 meters high, blows away the Saturn V. So this is the world's next heavy lift launch with the Orion capsule on. Its first mission is EM1, Exploration Mission 1. We'll launch it in 2018. And I'll show you what all the work, it's all about the people, the pride, and again, making sure that we're leading in exploration out into the universe. It will take us to Earth-Moon orbit and what we call deep space, beyond the moon during the 2020s. In Exploration Mission 1, Exploration Mission 2, 3, 4, 5, all the way through the 2020s, about once a year. So this is going on right now, testing the solids, testing the engines. That's animation, that's real. That's real bending metal. Coolest stir friction welding machine ever at our Michoud facility, putting those giant halves together. We'll reflect back on Earth, again, just that vantage point, that beautiful, blue dot, looking at spaceship Earth like we haven't seen it since we were there during the Apollo. But we keep going. The moon is not the destination. We get there to our proving grounds, but our horizon goal is Mars. This is entry, descent, and landing. That's hard. We can do it for 1 metric ton right now. The rovers, in 50 years, we've landed up to 1 metric ton, 2 metric tons. You're talking about people, we need 10, 20 metric tons. And it's not linear, it doesn't scale. So we have to figure out to keep our astronauts healthy and well and alive during these missions. So coming back to my favorite planet, which is spaceship Earth, Mars is number 2. And, but as Buckminster Fuller coined, and he advised Guy on some of his work, we really do need to reflect. And I don't think I'm ever bored. But I think I do spend time trying to reflect, and especially on spaceship Earth. Really, this is the far side of the moon that you see. There's not a dark side. For everybody our generation. So I want to tell you about this image. This isn't a PowerPoint, this isn't tricks, this is real scientific photographs from Earth. This is taken by our Discover mission. And our Discover mission is in a very special place. We have Earth, and we have the sun. Halfway in between is this wonderful point called the Lagrangian point, L1 we call it, and it's gravity neutral. So it's a weather buoy. Our Discover mission that took this picture sits in between of Earth and sun, and it sits there and it takes data from the sun and the sun's radiation, the cosmic rays that are coming our way. So it's a weather buoy and saying, what's coming to Earth, And I have a pre-warning. almost like a hurricane finder, if you will, telling us what kind of radiation, what kind of weather is coming to Earth. And then once a month, it takes these beautiful images when the moon orbits Earth. We get this. So it's my new screensaver. But again, reflecting and producing the science, but then also giving us views a million miles away off of our home planet. Right now, we have 28 Earth-absorbing satellites today. So there goes the space station, ISS, Zoom, that's where the people are living. Landsat adjacent to almost every satellite up there, looking at ocean temperatures, looking at ocean sea level rise, looking at soil mapping. Actually, we just had our crew on the ISS, the International Space Station. We're focusing our Earth observations right now on the great fires in Canada, so we can get some more images to help out in natural disaster. So we're continually looking and monitoring. From the orbital perspective, we can get pretty spectacular data and important data for Earth observations. And then I want to show you the last century of climate data. That NASA, we build and fly, design and fly the satellites. We work with our sister organizations, NOAA and USGS, to look at this and share the data. Okay, I'm born, Guy's already born, I'm born. Everybody in the audience, raise your hand when you're born. All right, now we have the millennials coming in. There we go. It's hot. So 2015 was the hottest year on record, preceded by 2014 was the hottest year on record. Guess what my prediction is for 2016? This scale, if you can see that, there is in Fahrenheit. I usually speak in SI units, but this one for a US audience, I put Fahrenheit just to make sure that there's no mistake. What you're seeing there is a 4-degree Fahrenheit shift when you get up to the top red. So it really is incredible, beautiful planet. This is new imagery that our astronauts took while they were on space station. I encourage you to go see that. The IMAX movie just opened up in New York a couple of weeks ago. And it's in Ultra HD. I'm not sure this projector shows it, but I want to show you, and again, bring you on our journey, bring you on our world, living and orbiting about 400 kilometers up, 250 miles, but reflecting, looking down on this beautiful spaceship Earth. It's a beautiful planet, but we need to take care of it. We need to understand it. I think we need to look at it as a system, a holistic system. Let you enjoy some of these. Another really important point for us at NASA, we're doing different kind of partnerships. This is a SpaceX's Dragon. It just undocked yesterday and was up on its 8th mission to deliver cargo. So we're investing in US industry. We have Orbital, ATK, also bringing us cargo. They both had accidents, but guess what? The commitment is hard work. They got back at it, all their engineers, and they're flying again. And we've just put Sierra Nevada Corporation as our 3rd contractor to deliver space station, because we'll be living and working on space station until 2024. That's Samantha Cristoforetti, an Italian astronaut who took some of these amazing images that you're looking at. That's Terry Virts, a NASA astronaut. Some of these things you can't do at home. There's Terry and Sam. She's actually doing a medical experiment, looking at interocular pressure in the eyes. So kind of like what's downstairs, but we have a new phenomenal, physiological phenomena. There's Scott Kelly. Probably know about Scott. I hope you know about Scott's 1-year mission. And pretty amazing. The first time that we at NASA could ever do a genetics experiment, because he has an identical twin brother, Mark, down here on Earth. Scott just landed in March. So we're doing their DNA sampling and sequencing, and we're looking at the microbiome really changes and how they're doing. It's only an N of 2. It's always fun to eat in space as well. He has a pretty nice breakfast burrito there. Each astronaut crew of 6 does about 250 scientific experiments in their 6-month mission. Again, Scott and his colleague, Mikhail Kornienko, the Russian, they were up last year, and we're looking at their muscles and bones. Here's Terry. He prefers cheeseburgers. So again, about 250 scientific experiments for, it's fun. Everyone plays Everyone plays with their food in space. It's pretty fun to be in microgravity and have things floating. And so, again, just my comments, and it really is it's a beautiful planet. It's a beautiful solar system. There's other beautiful galaxies out there. And but when we look, just take a look at some of these great images they just sent back. Pretty big weather. That was a typhoon over the Pacific. I leave on this, and I want to draw your attention to the blue horizon that is beautiful. That's our life support system. That's what separates life here on Earth from life non-existent or what we're looking for out in the solar system. So if I shrink Earth down to the size of a basketball, then our entire life support system is 3 human hairs thick. 3 human hairs thick on my basketball-sized Earth. So that's a way, I think, to look at the fragile, beautiful, pale blue dot that we call a spaceship Earth. And thanks for your attention. It's been a great audience.